Carbon dioxide is the primary greenhouse gas in the atmosphere. In 2018, it measured 411 parts per million at the Mauna Loa Atmospheric Baseline Observatory in Hawaii, setting a new record high. Of that, 5.2 billion metric tons of carbon dioxide gas were created from energy generation and use in the US that same year. These extra greenhouse gases in the atmosphere would trap infrared radiation by absorbing it and re-emitting some of it back to Earth. This would have the effect of causing the global temperature to rise, melting glaciers, and causing extreme weather events that would devastate billions of people. There have been many proposed solutions to this problem, but one that seems very promising is carbon sequestration. There are two main types of sequestration: geologic and biological. Biological sequestration occurs naturally and is the storage of carbon in the soil and ocean by plants and microorganisms. Forests, grasslands, and other plant-rich environments capture around 25% of carbon worldwide and can store it for decades. The destruction of rainforests and environments due to human activities reduces this effect, leaving more carbon dioxide gas in the atmosphere. Geologic sequestration is a process done by humans to store carbon dioxide within the Earth. This is done by first collecting carbon dioxide from power plants and factories and then transporting it to a carbon storage facility. The carbon dioxide flue gas is then passed through an amine solution which binds to the gas. It is then pumped to a tower where it is heated and the carbon dioxide comes out of solution so it can be properly stored. Carbon dioxide is then moved to permanent storage 1 to 3 kilometers below the seabed. The Sleipner Carbon Capture Facility in the North Sea has captured 19 million tons of carbon dioxide since 1996, equivalent to taking over 4 million cars off the road. The Sleipner facility is one of the largest scale projects of its kind in the world, but many more projects even larger than it would be required to make a big enough difference to stop global warming. The effects of geologic carbon sequestration haven't been fully researched though, and some people do have concerns that it will find its way into the water table if stored in unusable saline reservoirs or empty oil reservoirs. There isn't enough data to know if this is that big of a concern though, as most of the tests of the technology have happened in remote places under oceans. The only way to know if this technology will work or not is to try it on a much larger scale than it is currently being tested on. That is why we recommend that the US government invest in carbon capture technology and promote it internationally. Geologic carbon capture would work especially well in the US, as it is one of the small amount of climate change technologies that preserves the jobs of people working in industries that produce carbon dioxide. Biological carbon capture methods would also work well in the US, as it brings jobs to more rural areas that need new grasslands or forests planted.